Okay, this is the second example that we'll do of applications of logarithms and exponents. This is continually compounded interest, which we talked about in a previous section as well. Except again, we're going to solve for either R or T. R is the rate, interest rate, for continuously compounded interest rate. T is probably in years, although it would say when they give you the interest rate, it would say 3% per day or 3% per year. But usually they'll say annual interest of 3%, which compounded continuously or something like that. Okay, so it's almost the same formula that we just had, except there's no minus in front of the R because you're not losing money, hopefully you're gaining money. Okay, so you invest $5,000 at 3% annual interest compounded continuously. How long before your investment has doubled in value? Round your answer to the nearest 100th, or 1,000th. Sorry, can't read. 1,000th. So first, write out the equation without any numbers plugged in. Then write out all the values that they gave you. P-A-R-T, part. Okay. So P, they told me you invested 5,000. The interest is 3%. Remember, percent means per 100. So that is actually 3 over 100. So that number is actually 0.03. So R is 0.03. How long before your interest doubled in value? You invested 5,000. So double the value is 10,000. So that's how I got A is 10,000. Okay. This is a very common thing in finance. They call it the doubling time. The doubling time, turns out, doesn't depend on how much you start with. The doubling time, you could just put $1 in there and then $2 for A, $1 for P, $2 for A. You get the exact same answer. And you'll see why, because it just divides out. But it depends on the percentage annual interest, right, and how it's compounded. So if it's continuously compounded, the doubling time will be shorter if the annual interest is larger. So people in finance, a lot of times people working at banks, especially in the financial sections of the banks, usually have, for several interest rates, they have these memorized, what the doubling times are, because then they can make rough estimates for when will it be 4 times as much, things like that. Okay, so these are the numbers, and I don't know what T is, so I have to just solve for T, that's all. So the problems they give you in the book will basically like this. They usually write out what the equation is, they give you a bunch of values, and you'll have to solve for something that's in the exponent in this section, right? Either R or T, like what rate would you need? What would R be? Right, so I divided the 5,000 out. I got 2. You'll always get a 2 in these doubling time problems. And then they're kind of like a half-life, only going the other way, right? Okay, ln of both sides, right? And then on the right, I'll get 0.03t. Yep, 0.03t right there. Because these two cancel and that drops down, remember? You're composing two inverse functions, so the answer is going to be x, which in this case stands for this numerator. It's going to be the inside of the exponent function. Then you just divide both sides by 0.03, or cross multiply here if you want. Either way, same thing. And you get that. And that's approximately, they said to the 100th, they didn't say to convert it to days. If I were doing it for myself, I would want it in days. But they don't do that much in this text, so I just left it in decimal form. 23.105 years, that's what they asked for. Okay, and I know it's years because it was annual interest. And then I would kind of check that by plugging it in, see if I get 10,000. And this is just the answer button. There's an answer button on your keyboard. What it does is it just pulls up it on your calculator. There's an answer button. It just pulls up the last number that was up there. So if you just calculated this, and then you write out just write out 0.03 times answer, press the answer button, it'll multiply these two. Then you could take e to the answer, and then you could take 5,000 times answer. Or you could type this in just like it is. But remember, this is always the last number that showed up above. But the calculator, if you've got the one that I have in class, the official one, it shows 2 lines, so you can see this right above it. And if it's not right above it, then you have to scroll back to it, enter on it again, and then put this in. And it comes out to 10,000. That's just a short way. Of course, you could estimate it all the way through and see it come really close to 10,000 to check as well.